Hello guys, welcome to the next class on contour bund. In last class we have seen about up to step 4 depth of water impounding or water stored behind the bund. In this class we are going to see about the top width, bottom width as well as the side slope and the total earthwork volume and total area of cross section. All these items we are going to discuss about it. So clearly note down the formulas which are very much useful for you to solve the problems. So first we go into the step 5, bottom width of the contour bund. You see here, this is the side slope which is given in the contour. So take it as ZD plus ID. I denotes the seepage line of the slope and Z denotes the side slope. So according to this, we can write it this: the bottom width is equal to ZD, which is side slope plus depth of water impounding, and ID, which denotes the seepage line as well as the side slope depth of water impounding. So top width, the formula becomes B minus 2Z into H, which is B is nothing but the base width minus 2 into side slope into height of the bund. Here the height H denotes the height of the bund. So area lost, when you are doing the contour bunding, some areas can be lost. So sometimes the question may be asked to find the area lost in the contour bunding. So at that time you have to use this formula L into B into 1.3 area lost. 1.3 which denotes the side bund. You can write 1.3 when the side bund is not given in the question. So total earthwork volume is equal to A into L into 1.3, and the length per hectare is equal to 10,000 divided by HI, where you can mention 1.3 if the side bund is given. So the cross sectional area of the bund is equal to half into base width plus top width into height of the bund. So to find the total earthwork volume, how much amount of earthwork can be excavated from an area, it can be find out by using these formulas: 130S divided by vertical interval into cross sectional area. So side slope for clay soil, the side slope is 1:1. For loam soil, the side slope is 1.5:1, and for a sandy soil, it is 2:1. So first one denotes the Z is equal to for 1 and 1.5 and 2 for sandy soil. So we move on to the problem, which is very much easier to understand. Bunds are to be constructed to conserve rainwater in a farming having a 6% slope. Slope they had given us 6%. If the horizontal interval between the two bunds is 30 meter, they had given the horizontal interval. Horizontal interval is 30 meter, and there is no loss of water. The required height of the bund to store rainwater from 80 centimeter rainfall. Rainfall they had given 18 centimeter with a 10 years of return period. Here we want to find the D or H, which is nothing but depth of water impounding, where the water is stored behind the bund. So you know the formula D is equal to root of 2 into RE into vertical interval height. So to find the vertical interval, as you all know, the formula for vertical interval such as VA by HI is equal to S by 100. So slope they had given 6 by 100. So vertical interval we want to find. So VA divided by horizontal interval they had given us 30 meter. So when you calculated this, 6 divided by 100 into 30, 0 cancel, 6 3s are 18 divided by 10, 1.8 meter. Vertical interval we had taken as 1.8 meter. So easily you can put down in this formula depth of water impounding D is equal to root of 2 into rainfall excess they had given as 18 centimeter. You should return this 18 in 18 centimeter as meter, so that only we can get the answer commonly. So 0.18 into vertical interval we had find in meter only 1.8. So when you calculate this, d is equal to root of 0.648, which is nothing but 0.8049 meter. So here in question they are requested to find in centimeter. So take down, write the final formula. D is equal to 80.49 centimeter. 49 centimeter. This is the required answer where you got this. So clearly you want to find what are the data that is given in the question. So it is very much easier to solve this kind of problems and can get the score marks. Next question. This question is asked in UPSC 2022 where we want to design the dimension of the contour bund. So n number of formulas are we are going to apply. So clearly watch down how the formula is utilizing in this problem and the steps as usual. Let's read out the question. Calculate the design dimension of a contour bund in a medium deep soil having an average slope of 3%. The maximum expected rainfall during a 10-year recurrence is 20 centimeter. First write down the given data so that only the problem becomes easier. So average slope they had given s is equal to 3%. The maximum expected rainfall, the 10-year rainfall they had given us 20 centimeter. The infiltration capacity of the soil is a 30% of the rain infiltrated into the soil. Infiltration capacity is 30% of the rainfall potential. Rainfall potential. So the horizontal interval between the bunds is 60 meter. Horizontal interval also given, h is equal to 60 meter. Assume the slope of seepage line to be 4:1. Seepage line which is I 4:1, as well as the side slope also given. Side slope is equal to 1.5:1. The 1.5 denotes z:1. Okay. First, you want to find everything should be written in meter. So convert this into meter. You can get 0.2 meter. Okay. Then runoff potential is equal to runoff potential is equal to 70% of the rainfall. 70% of the rainfall. Whereas 40% is 30% is observed as infiltration. Observed as infiltration. So maximum we can find a maximum runoff to be stored. Maximum runoff stored is equal to 60% means 0.7, 70% means 0.7 into rainfall they had given 0.2. So the answer becomes 0.14 meter. Maximum runoff to be stored. Next, we are going to find out storage area required. Storage area required is equal to A is equal to maximum runoff to be stored. Maximum runoff to be stored into HI. Horizontal interval they had already given. You see in the question, horizontal interval they had given us 60 meter. So it is convenient for you to easily find out the storage area. So maximum runoff to be stored is we can find here 0.14 meter. So 0.14 into horizontal interval is 60 meter. So when you calculated this 0.14 into 60, you can get the answer as 8.4 meter square area. So area we had find here 8.4 meter square. Next, slowly we here find the vertical interval. So horizontal interval they had given us 60 meter. So slope also they had given. Slope they had given us 3%. So we can easily find out the vertical interval. Vi by h is equal to s by 100. So to find in the vertical interval, Va is equal to 3 divided by 100 into horizontal interval is 60 meter. So when you cancel this, vertical interval becomes 1.8 meter. Okay, vertical interval is 1.8 meter. And then, so next we have to draw the sketch of contour bund so that only we can easily find out the depth of water stored. So first to draw the sketch. So this is the bund. So here the line is going. So mark this as A, and this is D, and this is C, and this is B. So from here the C page line is connects the B. So C page, for C page we have find the value as given 4:1. So 4:, so we have written here 4:1, and here form a triangle. C page line, this denotes the C page line. So you can take this as E dash and this a particular point as E. So consider this point as F. So 1.5 denotes the side slope, 1.5 D, and here the area A2. We want to take the triangle A1 and A2. So the total water storage area is equal to A1 plus A2, which is nothing but A. So for A1 we can use the triangle, area of a triangle AFE dash, and A2 we have taken as area of a triangle AFE. So AFE, this is A2, and AFE dash, this is A1. So by the way, you have know the total area storage A is equal to A1 plus A2 is equal to A. A we have find out 8.4 meter square. So then we have to substitute this. Coming to the next slide, A is equal to A1 plus A2, where A1 is equal to half into D into 30D. As usual, A2 is equal to half into 1.5 D into D. So 8.4 meter square is the storage area we find out already. So putting these values, half into D into 30D plus half into 1.5 into D. So when you find out D is equal to, so after finding the D value, D is equal to 0.533 meter. So convert this, freeboard is nothing but 25% of the D value, depth of water stored. So when you put down this, you have get the freeboard value of 0.13325. And to find the height of the bund, the formula becomes depth of the water stored plus freeboard. So height of the bund is equal to 0.6625 meter. When you find the height of the bund, you can easily find the bottom width and top width using this formula. So take down and write the result: bottom width, top width, storage area, and depth of water stored, and freeboard and vertical interval. What are the things you find out? You have to write the answer. This is a 10-mark question. So keep updated. Thank you.